Hi guys, I hope you had a great Veterans Day yesterday, and as I told you, I can't be there today because my brother's getting married. And so the first thing I want to do today is go ahead and correct the homework assignment. And so you should have your pencils in the bucket and you should have green pens out. If you haven't done that, do that right now and we'll start correcting. So problem number 1 was x squared over 49 plus y plus 1 squared over 36 equals 1. And I always like to write what a and b are. So a was 7 and b was 6. The length of the major axis is always twice a, so 2 times 7 is going to be equal to 14. That's worth 1 point. And then your center is 0, -1. That's worth 1 point. And then you've got 2 vertices. One vertice is 7, -1. And the other vertice is -7, 1. And that's because you're adding the length of A to your center. So if you add 7 to 0, you get 7, and if you subtract it for the other side, you get -7. So each of those is worth 1. So far we have 4. Then you have to use the formula c squared equals a squared minus b squared to find the foci. And when you do that, you get c equals the square root of 13. That's the length from your center to each one of the focus points. And so that's going to give you foci of square root 13 -1 and opposite of the square root 13 -1. And that's another 2 points. And then last you have to find the latus rectum. And so you have to do 2 times b squared. Remember, b is 6. 6 squared is 36. 2 times 36 is 72. And so it's 72 over 7 for your latus rectum. And of course, if you made that into a mixed fraction, that's also okay, but no decimals. So I'm counting 1, 2, 3, 4, 5, 6, 7 points. So these are each going to be worth 7. And it's important that you put your score in green so these can get added to the grade book. Okay, number 2. Your center this time is going to be -1, 1. And that's worth 1. If you add the length of the A to that, -1 plus 6 is going to give you 5. And then -1 minus 6 is going to give you -7. So your 2 vertices are 5, 1 and -7, 1. And each of those is worth 1. If you double A, you get the major axis, and that is 12. And then if you do c squared equals your a squared minus b squared, you're going to get c squared equals plus or minus the square root of 11. And so when you take that and you add it to your center, you're going to get -1 plus the square root of 11, comma 1, -1 plus the square root of 11, comma 1, -1 minus the square root of 11, comma 1. I think then last latus rectum, b squared times 2 over 6 gives you 50 over 6. I simplified it because 50 and 6 are both divisible by 2. So the length of the latus rectum is 25 over 3. I will give you full credit if you left it as 50 over 6. And I will also give you full credit if you said that it's 8 1/3, but no decimals again, not 8.3. And so again, that was worth 7. And then the next one, your center is 1, 3. Your vertices are 1 plus the square root of 30, comma 3, and 1 minus the square root of 30, comma 3. And so 1, 1, and 1. And then your major axis is 2 times the square root of 30. And if you do 30 minus 15, you get 5. So C is equal to this plus or minus the square root of 5. So your foci are 1 plus the square root of 5 comma 3 and 1 minus the square root of 5 comma 3. And your lattice rectum, when you square the square root of 15, 2 times 15 over the square root of 30. Now what I did here is you have to simplify. So remember you're doing b squared. Well, b was the square root of 15. I always like to write that. And if you square the square root of 15, you get 15. So you're doing 2 times 15, which is 30, over a, which is the square root of 30. You can't leave it as 30 over the square root of 30 because you should never leave radicals in the denominator. So to get rid of it, you multiply this times the square root of 30 and also the denominator times the square root of 30. And when you do, that gives you 30 times the square root of 30 on your top, and on your bottom it gives you 30. Then 30 divided by 30 is 1, and 1 times the square root of 30 simplifies to the square root of 30. So again, that's 7. And on the last one, your center should have been 2, 3. Your vertices 7, 3 and negative 3, 3. Your C was 3, so your foci are 5, 3 and negative 1, 3. And then your lattice rectum, if you do 4 squared, you get 16, and 2 times 16 is 32. That's up here. I snuck it up here. And 32 over 5 is your lattice rectum, and that's also worth 1. That gives you 7. 4 times 7 is 28. You're going to put a score at the top of your paper out of 28. And then when you're done with that, you can put your green pens back in the bucket and get your pencils back out. You're going to get a big board over there at the back of the room. Please be careful of my vinyl graphs. And you are going to look at the GeoGebra applets that I posted under the resource center, under the resource section, of It's Learning. And I'm going to put some questions that I want you to try and answer while you play with those applets. So here are the questions, and then you can just keep this up on the screen. First, I want to know what the equation is for a vertical hyperbola, and that'll go on your big board. Everyone in the group should be helping write. Everyone should have the applets open when you start this. What is the equation for a horizontal? It's really sloppy. Hyperbola. Where will A always be? How will you find the length of the transverse axis? And last, how do you find the length of the asymptotes? Those are the dashed lines, the dashed diagonal lines. How do you find the length of the asymptotes? Actually, I don't mean the length, sorry, I mean the equation of them, because they're lines and so they have a linear equation. How do you find the equation of them? So you're going to use the big boards. You're going to make sure that you've answered these questions and you have looked carefully at that, and then another video will guide you through the process of the last part of class today on hyperboles.